These are the frequently asked questions for section 2-7, day 2 of pre-calculus. For number 23, they want us to solve the equation 2 over x minus 1 plus x equals 5. So the first thing we would want to do is put a 1 underneath those two terms, and that's because if you're working with fractions, it's always easiest to have everything be a fraction. And then we find our LCD. And our LCD in this case is that x minus 1 because our other denominators are just 1. And we would multiply each term by the LCD in its numerator. Here the x minus 1's are going to cancel. Here we'll have x times x minus 1. And on the right hand side of the equation 5 times x minus 1. So this will be 2 plus x squared minus x equals 5x minus 5. And we would always try to move everything over to one side to see whether or not something is factorable. So right now we have x squared minus x plus 2 equals 5x minus 5. And we would go ahead and subtract 5x from both sides and add 5. And that would look like so. So now what do we do? Well, we need to figure out exactly whether or not this can be factored or not. So we look at this and think, okay, we've got a plus 7, and that has to be a negative 6. So two numbers that multiply to positive 7 and add to negative 6. And really the only choices we would have would be negative 1 and negative 7, and positive 1 and positive 7. But obviously that's not going to add to negative 6x. So the next way to go would be to say, hey, let's complete the square. So move that 7 back over, making it negative, and then use our little b over 2 squared formula. So negative 6 over 2 squared is negative 3 squared, which is 9. So we're going to go ahead and add 9 to both sides. That will give us x minus 3 squared equals 2. And then we would take the square root of both sides. So x minus 3 equals plus or minus the square root of 2. And then we would add 3. So 3 plus or minus the square root of 2, and those would be our exact answers for number 23. And you could have, of course, put those back in and make sure that those are going to work. Or we could pop it into our calculator and check it graphically with the answers that we have of 3 plus or minus the square root of 2. You might find it to be off a little bit by rounding, but either way, that should work. And then number 27, let me clear the ink so that we can take a look at number 27. And number 27 has a lot going on. So for 27, what I'm doing is I'm writing it down is I'm thinking whether or not I can factor the denominator. And as I get to this denominator, that's exactly what I would want to do. So this is it does not have a common monomial factor, and it is not a perfect square trinomial, but we do have two numbers that multiply to negative 4 and add to 3, and that's going to be positive 4 and negative 1. And we see right away that that's a really good thing because our LCD includes both of those, the x plus 4 and the x minus 1. So now we would multiply each of these terms by that LCD of x minus 1 times x plus 4. And in the first one, the x plus 4's are going to cancel out. So we'll have 4x times the quantity x minus 1. In the second one, the x minus 1's will cancel out. So we will have 5 times x plus 4. And for the last one on the right-hand side, both of them are going to cancel out, so we're going to get 15. Distributing, we get 4x squared minus 4x plus 5x plus 20 equals 15. And then we would go ahead and combine like terms and get everything over to one side to see exactly what's going on here. So when we do that, we have 4x squared plus 1x, 20 minus 15 would give us 5. Looks like so. Now, we can try and factor it. We could do b squared minus 4ac to see if it is a perfect square with the discriminant, and then we would know that this is factorable, but I'm not going to waste your time here because it's not. So I would move the 5 back over. And then to complete the square, divide by 4. So now we need 1/4 divided by 2 squared. Well, 1/4 divided by 2 is the same thing as 1/4 times 1/2. And then we need to square that, so that will be 1/8 squared, which is 1/64. So we're going to go ahead and add 1/64 to both sides. That will give us x plus, well, what we just squared was 1/8. And then we have negative 5/4 plus 1/64. So we would go ahead and multiply our negative 5/4 by 16 on the top and the bottom. And that would give us a negative 80/64. So negative 80/64 plus 1/64 is a negative 79/64. And we would square root, and now we see the problem. We will have plus or minus the square root of 79 over 8i. These are going to be imaginary. We could find them. It's negative 1/8 plus the square root of 79 over 8i, and negative 1/8 minus the square root of 79 over 8i, but we don't have any real solutions. So all that good math, I mean, that was a lot of fun algebraically there, but we're not going to get an answer. It just is not going to happen. Number 51 was another one that you had asked for, and it said, consider the equation which we solved in example 4. So for 51, if we went back and looked at what we solved, we found out this had no solution. No solution. Now for part A, it says, instead of having it equal 0, just think of it as a fraction that we have to combine. What would that equal? So what we would normally do is say, all right, well, let's factor our denominators. So x minus 3 over x plus 3 over x plus 2 equals 6 over x times x plus 2, or not equals, sorry, there's a plus there. Keep thinking about the solve from the first one, and this time we're not solving it. So now what we do is build these fractions up so they have a common denominator. This one would need the x plus 2, and this one would need the x, and this one wouldn't need anything. So our 6 over there is going to be just fine. Now if we multiply this out, we're going to get x squared minus x minus 6 over x times x plus 2 plus 3x over x times x plus 2 plus 6 over x times x plus 2. And then we would go ahead and do the addition because we do have a common denominator so that we can go ahead and combine. And that would give us x squared plus 2x. Now it said, don't reduce it at the end, so we're supposed to leave it just like that. And then B says, if that is our answer, what is the domain of f? Well, our LCD was x times x plus 2. So our domain would leave out, we'd go from negative infinity, again think number line, to negative 2. We'd hop over negative 2 and go to 0, but then we'd have to stop, hop over the 0, and go on to infinity, because right here we can see x can't be 0 and x can't be negative 2, so we have to make those hops. And then C says, if you want to graph this, define it as a piecewise function. So we think, well, if we define this as a piecewise function, that would mean we want to take a look at this in its most basic form, and that's going to be 1 equals f of x. So f of x equals, well, we just got done saying this will graph as 1, a horizontal line, but not all the time. So what we have to do is say it's going to graph as 1 on the interval negative infinity to negative 2, union with negative 2 to 0, union with 0 to infinity. But it will be undefined for x equals negative 2 or 0. So there's only two choices. It's either going to look like the horizontal line y equals 1, or we're not going to be able to graph it. It's going to be undefined. And then the last portion says, graph it. Explain how the graph supports your answers in B and C. Well, it's going to be 1, except we know that we're going to have a hole at negative 2 and at 0. So there it is. And if you graph this on your graphing calculator, we might not see those holes with some of the different models of calculator that we have, but what you might see is a small break. And that small break is actually the calculator trying to give you a hole. That's what it's trying to do. So when they say graph F, they're saying go back to our result that we had, put that in your calculator and see what you get. You can't put y equals 1 into your calculator unless you're going to punch in that piecewise function that we had there. And my writing to learn, graph F and explain how the graph supports your answers in B and C. For D, we would say it is a horizontal line with holes at negative 2 and 0. And that supports what we had in the math.